Hello friends, myself Salil Gadgil. I am a mathematics teacher and I have also authored a couple of math workbooks. I am here to clear a few misconceptions related to exponents in this video. Let's get started. So the first misconception that we are going to clear is a raised to n plus or minus b raised to n is a plus or minus b the whole raised to n. So what is the source of the misconception here? Students think that just like taking variables out as common, they can also take these powers as common. So they have taken n and n out as common and they have written this a plus b inside, a plus or minus b, and that is how they solve the problem. So for example, if I ask them what is 5 raised to 2 plus 2 raised to 2, the answer that they give is 5 plus 2 is 7, so 7 raised to 2. Let's see if this is really true. How much is 5 square? 5 square is 25, 2 square is 4 and 25 plus 4 is 29. And how much is 7 square? 7 square happens to be 49. You will notice that these two sides are not equal. So this is not really true. Or if you ask them how much is 5 square minus 3 square? They tend to think, oh, squares can be taken out as common. So let me do 5 minus 3, which is 2, and 2 square is going to be 4. Let's see if this is really true. How much is 5 square? 25. How much is 3 square? 9. So 25 minus 9 is going to be 16, and 16 is definitely not equal to 4. So what is the mistake that they are doing over here? You cannot take powers out as common because that is one fundamental difference between the variables and the operators, as I explained in one of my videos. Over here, taking out the power out as common is not acceptable because you can do that with variables, you cannot do that with operators, because the operators are actually trying to change the value of the number. So you have to apply the operator to the individual numbers and then perform the addition or subtraction operator. In other words, if you have heard of this term BODMAS, or in some cases they also name it as PEDMAS, here you are finding the power of A, so that comes under the O category, right? You are finding the power of. That's why before you add or subtract, you should first be finding the power of the number and then you should be adding or subtracting. So let's find the right way to do these particular operations. So if somebody told me to do 5 square plus or minus 2 square, I would do 5 square first, which is 25, plus or minus 2 square. 2 square happens to be 4. So if the operator is plus, then 25 plus 4 would be 29. Or if the operator is minus, I would do 25 minus 4, which is 21. So this is the right way of doing this particular problem. Because O precedes addition and subtraction, you are supposed to deal with the operator first and then perform the addition subtraction. Now, had this been multiplication or division, then you could have done the whole raised to n, because, so what I am trying to say is, if it was a raised to n multiplied by b raised to n, then you could have written this as ab the whole raised to n, and that is because exponents primarily deals with multiplication and division of numbers. Exponents is repeated multiplication, and that's why had this been multiplication or division, then you could have taken the power n as common. You could have first multiplied a and b and then you could have found the answer as whole raised to n. So a raised to n multiplied with b raised to n can be a into b the whole raised to n, or if it's division, it can be a divided by b the whole raised to n. But when it comes to addition or subtraction, it is not allowed. I hope that this misconception was cleared. Now let's go to the next misconception. The second misconception is a raised to m plus or minus a raised to n is a raised to m plus or minus n. What is the source of confusion here? The bases are same. So you have addition, subtraction between these two. So students tend to shift this particular plus or minus into the powers. For example, 3 raised to 6 plus 3 raised to 2 is written as 3 raised to 6 plus 2. They see a 6, you see a plus, you see a 2. So 6 plus 2 becomes 8, right? Or 3 raised to 7 minus 3 raised to 3 becomes 3 raised to 7 minus 3, which is 4, correct? So what students tend to do is, if they see a plus or minus sign in between and they see the same base, they tend to subtract or add the powers. Now this also is wrong. So let's understand why it is wrong. Again over here, there are two operators that are being used. One is the exponent operator, 3 raised to 6 and 3 square, these are exponents, and there is a addition operator being used. So what does BODMAS tell us? BODMAS tells us that before you perform addition or subtraction, you should perform the operation first. That means you are supposed to find 3 raised to 6 first, evaluate it separately, and then evaluate 3 square separately and then add the 2. So the right way of doing it would be 3 raised to 6 is going to be 729. 3 raised to 6 is 3 multiplied by itself 6 times, plus 3 square is going to be 9. So 729 plus 9 is going to be 738, and that's going to be your right answer. 3 raised to 7 minus 3 raised to 3. So how would you perform this? Again you have a subtraction operator. You also have an exponent operator. Who takes precedence here? The exponent part takes precedence. So we need to perform 3 raised to 7, which is 2187. If you calculate, if you multiply 3 with itself 7 times, you will get 2187 minus 3 cube is 27. So 2187 minus 27 is going to be 2160. Moreover, the other way to explain this would be the laws of exponents or the rules of exponents apply only to multiplication and division, because exponents is repeated multiplication. That's why exponent laws are very friendly when it comes to multiplication and division. They are not at all friendly when it comes to addition or subtraction. And that's why even if you have plus or minus signs between these two, you cannot carry these on to the powers. That is absolutely wrong. Rather, a raised to m plus n according to the product law is written as a raised to m multiplied by a raised to n. Instead of addition, actually it is multiplication. The right law says a raised to m plus n is a raised to m into a raised to n. And why is it so? Because a raised to m means multiply a m number of times. So you are multiplying a with itself m number of times. Multiplied with a raised to n means you are multiplying a with itself n number of times. So when you now multiply all this, that is the difference. Here you are multiplying m a's with n a's, which means in the result you are going to have m plus n a's, which is same as a raised to m plus n. So this is called the product law in exponents. And similarly the quotient law says a raised to m minus n is a raised to m divided by a raised to n. In these laws, if you notice, these laws cater to multiplication and division rather than addition and subtraction. So don't ever try to take the plus or minus signs between these two values into the powers. This concept is wrong, or rather it is a misconception. I hope that this segment cleared out this misconception. Now let's move on to the next misconception. So moving on to the last misconception, a raised to m divided by b raised to m is a by b. What is the source of misconception here? M and m cancel out each other. So that is the reason why students tend to think a raised to m divided by b raised to m is a upon b. Is it really true? One fundamental difference between operators and variables is you cannot cancel out the operators. You can cancel out the variables, but you cannot cancel out the operators. So when you have a raised to m divided by b raised to m, it basically means a raised to m is a multiplied by a multiplied by a, how many times? M times, divided by b raised to m is going to be b multiplied with b multiplied with b, how many times? M times. Do you think this value is equal to this value? Over here I only see one a and one b. I see one a in the numerator and one b in the denominator. Whereas in this case there are m a's getting multiplied in the numerator and m b's getting multiplied in the denominator. Definitely these values are not equal unless a or b, a and b both were equal to 1, or maybe a was equal to 0, right? Rather what I see over here is I see a pair a by b, I see another pair a by b, I see another pair a by b, and I see m such pairs of a by b. So what is the modification that I should do over here? I see m pairs of a divided by b, and therefore a raised to m divided by b raised to m should be written as a by b the whole raised to m. So for example, 6 cube divided by 2 cube, students tend to write this as 3 cancels, assuming that they were variables, but they are actually not variables, they are operators. So 3 would cancel and 6 by 2, the answer would be 3. But what is the right way to calculate it? 6 divided by 2 is 3 indeed, but these powers don't cancel out, the power remains as is. So it becomes 3 raised to 3. Or if I had 10 raised to 10 divided by 5 raised to 10, students tend to cancel out the powers 10, right? Thinking that you can cancel out variables, so similarly you can cancel out the exponents or the powers also. Not true. Rather 10 divided by 5 is 2, that's right, but the power would stay as is. So 10 raised to 10 divided by 5 raised to 10 would be 2 raised to 10. Moral of the story, if you have the same exponents or the same power and you have division of two numbers, then you can divide these two numbers, you can find a by b, but that a by b should be raised to the power. So I hope that all the misconceptions in exponents were clear and you will not repeat these mistakes when you perform your calculations. So I hope that you found this video interesting and it helped clear some doubts that you may have had in the past. In the next video, I'll come up with some new idea, some new concept. Do like, share and subscribe my YouTube channel and stay connected for more updates. Till then, goodbye.